When it says that you need to factor completely, that typically means there's going to be more than one step involved. It doesn't mean that it's more difficult, it just means there's a couple different factoring techniques that you might have to employ. So in example 1a, x to the third minus 4x squared minus 5x. The first thing that you should always check is, do the terms have anything in common? Is there a greatest common factor that you could pull out of every single term? So take a look at those three terms. Is there anything they have in common? They all have an x. So we're going to pull the x outside of the parentheses. When I teach this to my Algebra B classes, I actually have them write divided by x underneath each term. If that helps you, great. If you don't need that, great. So x to the third divided by x, it cancels out one of those x's and leaves us with x squared. Negative 4x squared. Take out one of those x's, you'd be left with negative 4x. And negative 5x divided by the x leaves you with negative 5. Now we need to factor the trinomial x squared minus 4x minus 5. Some of you hopefully remember that you need to find two numbers whose product is negative 5 and whose sum is negative 4. Now what if you're trying to factor and you cannot remember? You know that you're supposed to do blank times blank, blank plus blank, but you don't remember, am I multiplying to get the negative 5 or am I multiplying to get the negative 4? I don't remember. Check out what happens if you just pick two random numbers, like 2 and 3. X plus 2 times x plus 3. If we were to multiply that out, we would get x squared plus 3x plus 2x plus 6. Notice that the 6, we got that by multiplying the 2 and the 3. The 3x and the 2x, which would be the 2 and the 3, we add those together to get the 5x term in the middle. So try multiplying out two binomials, and that will help you to remember that you are multiplying to get the last number and adding to get the middle number. Okay, back to our problem. What numbers multiply to give us negative 5 and add up to negative 4? 1 and negative 5. So the factored form, don't forget about that x in front that we already factored out. X plus 1, x minus 5. When you have all plain ordinary x's in the parentheses, you have fully factored it. It is done. Get started on B on your own. See if you can figure out what the greatest common factor is for B. These two things, we can divide both of them by 3 and y to the third. If you're struggling with finding what the greatest common factor is, please let me know. Come into Wildcat Hour, come in before or after school, or ask me during work time. I have ways to help you figure out what the greatest common factor is. Here's what I do with my Algebra B classes. We look at 3y to the fifth. 3 we can do 1 times 3, and y to the fifth means y multiplied together 5 times. 48y to the third. Because 3 is the biggest number underneath 3y to the fifth, I'm going to try 3, and I can do 3 times 16. And y to the third means y times y times y. So what do these things have in common? They have 3 in common, and they have 3 factors of y in common. So your greatest common factor is 3y to the third. And then look what happens when you take those out of here. You're left with y squared and 16. So 3y to the fifth divided by 3y to the third is y squared. And negative 48 divided by 3 is negative 16. We're pulling all of those y's out. Is that problem done? We still have y squared inside the parentheses, so we are probably not done. So step 2 is to either factor using your blanks or Sometimes we factor using the difference of two squares. Do you guys remember the difference of two squares? One of them's plus, one of them's minus. So when you have something squared plus something else that's squared, the factored form is a plus b times a minus b. So y squared is the perfect square of y, and 16 is the perfect square of 4. So don't forget your 3y to the third outside of the answer. Y plus 4, y minus 4. Okay, in example C, first of all, these three terms have 5z squared as a greatest common factor. 5 divided by 5 is 1. Z to the fourth, take z squared out, you're left with z squared. 30 divided by 5 is 6. Z to the third, take out z squared, you're left with a z. 45 divided by 5 is 9. Z squared, take out z squared, you're left with no z's. Now we do the blanks. Blank times blank equals 9. Blank plus blank equals 6. What numbers satisfy that? 3 and 3. So you could write your answer like this. 5z squared times z plus 3 times z plus 3. But do you notice that z plus 3 and z plus 3 are exactly the same? If the parentheses are exactly the same letters, same numbers, same symbols, exactly the same, you can write them, go away calendar, as 5z squared times the quantity z plus 3 squared. All right, here's the deal with the sum and difference of two cubes. Something like x to the third minus 125. That's our first example down here. X to the third is the perfect cube of x. 125 is the perfect cube of 5. So we could take x to the third plus 0x squared plus 0x minus 125 divided by x minus 5, and we could factor this using long division or synthetic division. Or we could use this little shortcut called the sum or difference of two cubes. These patterns are exactly the same. You just have to figure out which symbols to use where. So I have a feeling that most of you don't have your perfect cubes memorized. There's a list of perfect cubes in your notes. You can always come up with these by grabbing your calculator and doing 2 cubed, write it down, 3 cubed, write it down, and so on and so on. So here's how the pattern works. You first need to figure out what each term is the perfect cube of. So x to the third is the perfect cube of x. 125 is the perfect cube of 5. So in this pattern, and we're going to use the difference of two cubes pattern because our original symbol is minus. In this pattern, a is our x, and the b is going to be our 5. So it says in the first set of parentheses, do a minus b. So x minus 5. In the second set of parentheses, it says square the first one. So take x and square it. X squared. Then it says plus ab. That means plus, and then multiply those two things together. What is x times 5? So plus 5x. And then it says b squared. So take the second one, 5, and square it, 25. Now you could try to factor this polynomial, but I guarantee you there are no numbers that multiply to give you 25 and add up to 5. So this is done. This is fully factored. That's it. All you have to do is memorize the pattern and bam, it's factored. It's like that for all of the sum and difference of two cubes. Now let's look at the patterns. I want you to notice the patterns are exactly the same. A, B, A squared, AB, B squared. It follows that pattern for both of them. The addition or subtraction in the first set of parentheses matches the original problem. So if it's the sum of two cubes, the first set of parentheses will be plus. If it's the difference of two cubes, the first symbol will be minus. The second symbol is the opposite of whatever symbol you used in the first set of parentheses. The last symbol is always plus. All right, let's try B. B is the sum of two cubes. A cubed is the perfect cube of A. 27 is the perfect cube of 3. Because this is the sum of two cubes, we are going to do A plus 3, A squared. We used plus in the first set of parentheses, so we use minus next. A times 3 is 3A. Always use plus for the last one. 3 squared is 9. Factored. So try C on your own. So we've got x and 7, and it's a difference of two cubes. So x minus 7, x squared plus 7x plus 49. How did you do? Oops. Okay, now take a look at E. The problem with E is that we don't just have x cubed. We have 64x cubed. What is 64 the perfect cube of? 4. And x cubed is the perfect cube of x. So our A is actually 4x instead of just x. 27 is the perfect cube of 3. It's sum of two cubes, so the first part's easy, 4x plus 3. This next term is the most commonly missed problem. If we square 4x, we aren't just going to tack a square on it. We have to do 4x times 4x. What is 4x times 4x? 16x squared. Then we're going to use minus because we used plus in the first set of parentheses. Multiply these two things together. 4x times 3 is 12x. And then square 3, 9. Done. Okay, what you might notice about F is that 16 and 54 are not perfect cubes. S to the 5th is also not a perfect cube. So in F, what do these two terms have in common? They definitely have s to the 2nd in common, and they're both even, so we can divide them both by 2. 16 divided by 2 is 8. 54 divided by 2 is 27. Now I would like you to try to finish example F on your own. 8s cubed. 8 is the perfect cube of 2. S cubed is the perfect cube of s. 27 is the perfect cube of 3. It is helpful to write those down so you can have those to look at. Our answer, don't forget the 2s squared out front. It's sum of two cubes, so 2s plus 3. This term is the tricky term. You have to take 2s times 2s to get 4s squared. You can't just tack a square on it. You have to multiply that term by itself. Then we're going to use minus because we used plus in the first set of parentheses. 2s times 3 is 6s. And then 3 squared is 9. It's always plus at the end. So 2s squared times the quantity 2s plus 3 times the quantity 4s squared minus 6s plus 9.